Hi, my name is Sam, and I'm a co-founder of AutoDataMiner. In this video, I am going to show how AutoDataMiner can help oil and gas industries to analyze their data. For this purpose, I've selected a well-logged dataset, and I will go over all the steps you might take to analyze this data through AutoDataMiner. Let us start. So I have actually a well-logged dataset, as I said. So this dataset is actually called historical data. If I open it, you see, I have a bunch of records. Actually, this is a CSV file, and I have around like 2,100 records here, and I have in overall 9 columns. So the first column is called depth, the second one is called like gamma ray, another one is resistivity, and then we have like neutron density, porosity difference, average neutron density, porosity. We have like a photoelectric effect A, and then we have non-marine, marine indicator, relative position, and then the last one is called Facies class. So you can see we have, various, measures of different kind of indicators here. So, in oil and gas industry, especially, I would say, like analyzing well-logged data is very important, especially to predict Facies classes. In fact, the Facies class is a very important piece of information, and actually predicting this class is very helpful for exploration, for prospecting, for reservoir characterization, and even field development. So in this analysis, we are going to actually, first of all, do a very, deep, analysis for this data. Get some deep understanding about this data, and then at the end, we try to predict this value through the other columns. So let me close this file for now. So if you log into the like AutoDataMiner, you'll see a link called analysis. So again, if you log into the system, you can see it. Otherwise, you will not be able to see this link. So if I click on this analysis link, you'll see the previous projects here. So by clicking on this links, actually, I can see my previous projects. Another option here I have is starting a new analysis. So and you can just select your data set and then start your analysis. So what I'm going to do, I'm just going to select the historical data I already talked about, and then open it and then upload the data. So when I upload the data, I need to answer to 3 questions. The first question is, please select the name for analysis. Very simple. So I would say demo, I would say well-log data, log data, kind of, yeah, I just call it demo well-log data. And then in the next step, you need to select the fields that you would like to consider in analysis. So here, actually, these fields actually are the one that we had in that data set. If you remember, if I open it again, these are the fields, right? These fields actually are showing up here as well. So now you can select which one of these fields you would like to consider for analysis. Sometimes you have some fields that are not really important. For example, you have a record number, or you have, something, let's say operator ID. These stuff might not be very significant when you're doing this kind of analysis. And if you don't know which one is significant, which one is not, then it doesn't matter. You can even select all of them, and then the algorithm, the system decide which one is important for you, and then it will generate a report based on that. So the third column is called target column. So you need to select a target column. So it's explaining a target column is a column that you would like to see the impact of other columns on it, or you would like to predict its values using other columns. So if you don't have a target column, fine, you don't need to actually select anything. But if you have, you can select it. So here, actually, if you remember, we are kind of very interested to Facies class, right? So we are then, I would say we have a target column, Facies class. So after answering to these, 3 sections, you can just start your analysis. So based on the like the size of the file that you uploaded, and based on the number of columns that you have in your data, and then based on how, for example, the server is busy, it takes between 1 to 5 minutes for the system to generate your dashboard. Again, I would say for this file, for this data, because the file was very small, I would say it's going to take even less than a minute to generate your analysis. So another actually option when you're, when this system working to generate this dashboard, actually you can just close it and then, do your other stuff and then return and just click on the analysis link, and then you'll see it. When the system generated the dashboard. So after generating the dashboard, actually you have six tabs, actually 6 types of analysis the system generated for you. Summary stat, dependency analysis, cluster analysis, anomaly detection, and then impact and prediction analysis. So you see a whole bunch of, like, I would say, machine learning related analysis provided for you through this dashboard. So let's go one by one. So summary stats. So summary stat, you know, as I mean, you can see from its name, it's just giving you a summary of statistics of the data for each column. So you have, again, all the columns, you had in your data, and then you have, for example, the type of the column, for example, if it is numeric, or for example, if it is categorical, how many missing values you have, how many unique values, what is the mean value, median value, standard deviation, minimum, maximum, most frequent, and least frequent. So you get a whole bunch of, I would say, like stats, basic stat about each column. And the last actually column is very interesting. So this column actually, in this analysis shows the distribution plot of each actually, I would say, attribute in the data. So if I just click on the show plot, so I can see, for example, a very nice visualization and interactive actually visualization of the selected column, which was depth, right? So you can, for example, see, for example, how many like instances you had in your data for different values of depths. So another one is, let's say, gamma ray. If I click on gamma ray, so you see, for example, this is the distribution of gamma ray in the records that I had. Or another one, for example, Facies class. If I click on that, so you'll see I had 6 classes actually, like non-marine standalone, and then non-marine fine, like siltstone. So anyway, so you have actually, kind of very interactive visualization for each columns that you would like to analyze in this analysis. And again, you can see, for example, here we have 553, for example, of this class. Here we have, for example, 194 instances for this class. So it gives you a very kind of deep understanding about your each field actually in your data set. So the second analysis is called dependency analysis. So in dependency analysis, we try to create any pairwise, I would say, any combination of between every 2 columns, and then see what is the interaction between these 2 columns. Is there any correlation between these 2 columns? Is there any dependency? If the correlation is positive or it is negative, is that weak or it is strong? We have, we are providing all those kind of, I would say, like insight about your data. So for example, if you consider depth as the first column and then gamma ray as the second column, you can see that the correlation is weak negative. And then if I just show the interaction plot, so you'll see actually an interaction plot between gamma ray and depth. And like, for example, here you can see for at these depth at these depths actually we have very high values sometimes for gamma rays. So this might be I would say an anomaly or error, or I don't know, maybe something happening in this depth. So I'm not actually an expert in this field, but anyway, so I'm just closing it. I'm not gonna go over all of these interaction plots, but let's consider, for example, another one. For example, let's consider resistivity and Facies class. And looks like the correlation is moderate. If I just show the plot, so this is actually the plot. So you see, for example, for different Facies classes, you have this is the distribution of the resistivity. For example, for waxstone, you can see we have higher resistivity, I would say, in this data set. You can see, for example, this line is actually median, and then you can have like minimum, maximum, difference, like the different stat actually about each of these plots. Anyway, so let me close this. So the next one is cluster analysis. So cluster analysis, you know what clustering is. So cluster analysis tries to kind of group similar data into the same groups, and then you can analyze similar data with together. So here you can see actually this is a kind of projection of the data set you have. And actually here the algorithm decided to have 6 clusters. So actually it's very, very interesting. The system was intelligent enough to identify that when we are grouping our data sets, actually there are 6 different groups in data. So you can see, again, this is cluster 1, cluster 2 to cluster 6. For example, for cluster 1, you see I mean, most of, I mean, in majority of cases, the depth is not very different. Or, but for example, if you go to the next one, like gamma ray, you see, for example, here we have a very high, for cluster 1, we have a very high gamma ray, or for cluster number 3, we have a very high gamma ray, but for example, for cluster number 2, we have a very low gamma ray. So if you see here, in fact, here, actually, these are actually very strong indicators when we are creating the clustering. So you see, for example, facies class, when this is milestone, here, and then this is actually, I would say, the overall characteristic of this guy, this milestone. Or when, for example, here, when we have the other one here, for example, we have one, this is the characteristics of this guy, this class. So in this way, actually, you're going to get a bunch of, a group of data, and then you can analyze your data based on grouping. So again, and then here, actually, you have, the previous data set that we talked about, and then here we have, for example, the cluster label. What was the cluster? And then we have the record number. So if you just go down at the end, in fact, you can download this table. So if I just download this table and just open it, so you see I have, the previous data set, and then I have two columns, added to this data set, which is, for example, the first one is like cluster label, the second one is like record number. So if I just, for example, let's say sort my data based on the cluster labels, so you see, for example, these guys are coming into cluster number 1. Up to here we have like cluster number 1, and then we have cluster number 2. An interesting thing is like the data kind of like clustered. The algorithm was able to cluster data. Kind of, it was intelligent enough to kind of see that there's a big difference between different classes. So that's why it did cluster the data based on classes. And it's very interesting, actually. Anyway, so if I go back again to the previous analysis, so I have anomaly analysis as another analysis. So you see, for example, these blue dots actually are normal data, and these are actually top 5% of anomalous data. So what you can do again here, for example, if I put the mouse here, you can see, for example, the record number 63 is an anomalous record. So you can then go to your data. For example, here I have the data. If I go to record number 63, and then I can see why this actually this record is anomalous. And again, you can like download the table and again open it, and then go to record number 63. As I was talking about, like this guy is an anomalous record. I don't know why. You can take a look into it if you're an expert in this area and see what's going on here. So anyway, so now let's go to the actually, I would say, two most important piece of our analysis. The first one is called impact analysis. So in impact analysis, we are trying to see the impact of other columns on the target column. And because here we have 6 classes, you can see we have this system actually generated 6 types of impact analysis for different classes. So for example, here it's talking about considering target as facies class equals to Wagstone, and this is actually this is a logistic regression. So you see, for example, the feature, the coefficient, the odd ratio, probability impact, and p-value. If you have a good background in, if you have good knowledge in stat, then definitely you can understand this. But otherwise, it doesn't really matter, because you can, we have the interpretation of these numbers in a very easy way, for everybody to understand. So you can see, for example, here again for this class, facies class equals to Wagstone. So we have here 1 unit increase in resistivity increases the odd of facies class by this times. In other words, it increases the probability of facies class equals to Wagstone by around 72%. So when you increase the value of resistivity just in one point, then the probability of having this class goes up by 72%. It's huge. But don't forget, one unit increase for resistivity is a lot, because if you remember, if I go back to the summary stat and go to resistivity, resistivity is not a big number. It's actually something between, I would say, 0 to this one, right? So usually 1 unit is a lot. So definitely it's going to change. It's going to really like increase the chance of being Wagstone by 72%. It's huge. If we go back to impact analysis, so this was the first class. So if you go to the second class, this one, so if the facies class is this class, then these are the logistic, the coefficients for the logistic regression, and this is the interpretation of result. Let me read one of those. For example, 1 unit increase in relative position increases the odd of facies by this, And then in other words, it increases the probability of Facies class, this class, by around 11%. So easily you can kind of get a very, I would say, deep insight about your data by doing this, by running, by reading this impact analysis. And then the last, I would say, the last piece of analysis is called prediction analysis. So in prediction analysis, actually we have provided our C curve. So here we have different classes, and then numbers close to 1 means a very better, I would say, prediction strength. So you see, all these classes, and there are C curve, and I would say in majority of cases, actually, the system was able to predict the class in a very, accurate way. And then we have another one called precision recall curve, and again, a number close to 1 means a very stronger, for example, prediction. For example, if you see here 92, for example, for this class, we are more, we are stronger to predict this class. So again, these are actually some technical stuff, especially for like stats, people, or like even data scientists. So the last, I would say, a plot here. Actually, this is a very interesting plot. It's talking about like feature importance and prediction. Which columns are more important when you're trying to predict a Facies class. So you can see, for example, resistivity is the first one, and then gamma ray is the second one, depth is the third one. So you see how important those features are when you're trying to predict the Facies class. And then the last step, what you can do here is you can actually upload a new data, and then the system can predict the Facies class for you based on the model that it already learned. So if I go back to my previous data set, I had here something called new data, right? So if I open this new data, I would say the same columns as the historical data, right? But I don't have the Facies class here. I have everything except the Facies class, right? I don't have like Facies class here. So what I can do, I can give this data set, just make sure that you have the column names are exactly the same as the historical data that you uploaded. Otherwise, it's not gonna work. But if you have all the columns that you already used to build your analysis, except the target column, which was Facies class, then you're good to go. So you can just upload this file. I'm just gonna actually send this file to this system and ask the system to give me a prediction value for those values. So I just choose the file here, and it was called new data. I just open it and upload the data. So what happens after a couple of, I would say, seconds, you get a prediction analysis here, save it, and then open it. So now, if you see, you have the previous data set. Actually, this was the new data, and here you have actually a predicted class for it. So for example, for the first record, the predicted class is this one. And even it gives you a very actually nice information about the other classes as well. So it gives you the probability of this record being, like belong to, like to the other classes. For example, you can see here, the probability for this class is 71%. That's why this class actually was selected, right? Non-marine, course, this one selected. For the probability for other classes is very low. Or for example, for this guy, this class is very strong, and then the class predicted for this guy is this one. So you can see, in this way, you can see, first of all, how strong the prediction is for each class. And then, for example, let's say at some point you have, the numbers are very close to each other. So then you would say, the system, is not able to kind of have a very big difference between different classes when it's looking at this record. But again, you have, all the predicted classes, and then, you have the probability for each class, and then you can, use this information, for your task. Yeah, that was it. Yeah, if you had any question, just send us email, and we definitely be happy to talk to you guys. So thank you for watching this video.